Hi, physics class. This is your assignment for Wednesday, April the 15th. It's on Newton's third law, and we're starting to get in now to some lessons that we did not cover before school closed. So let's go ahead and get started with this. So Newton's third law of motion says that for every action, which by that word, that's Newton's word, he means a force. There's an equal and opposing reaction force. So we really don't use the terms action, reaction. For every force, there's an equal and opposing force. If forces on an object are not equal, then the object will accelerate until the forces become equal again. When forces are equal balanced, the object is in equilibrium. When forces are not equal unbalanced, then the object is in disequilibrium. Objects that are in disequilibrium, unbalanced forces, accelerate until the forces are balanced again. So let's just say you weigh 100 pounds and you're standing on a floor. You're pushing down on the floor with 100 pounds of force, but the floor is also pushing back on you with a reactive force, an opposing force of 100 pounds of force. If those two forces weren't equal, we remember from our discussions of balanced and unbalanced forces, if those two forces weren't equal or balanced, you would be accelerating or the floor would be accelerating. If you jump out of let's say you jump off of the top of your house, hopefully not too high, but let's say you jump down to the earth. The earth is pulling on you with a force, but you're pulling the earth back upward with exactly the same amount of force. So while you're moving downward because the earth is pulling you downward, as strange as it may sound, you're pulling the earth upward towards you. It's just that the earth is so massive that amount of distance that you're causing the earth to move is immeasurable. It's too small to even be measured. But the earth, just as the earth is pulling you down with a certain amount of force, you're pulling the earth back up toward you with the same amount of force. But your motion is obvious that you're falling. It's not obvious that the earth is moving at all towards you, but in some little tiny way, it really is doing that. All right, friction forces. So friction force is a force that opposes motion by one object contacting another object, such as moving a desk across a floor. There's two types of friction. We'll just kind of point these out. One is static friction. That's the friction. Static friction is the friction keeping an object from moving. Dynamic friction is the friction that's slowing you down once you get the object moving. If you've ever tried to push a heavy box, you know it takes a little bit extra energy to get the box moving. Let's say it's on kind of a smooth floor. It'll take a little extra energy to get the box moving, and then once it's moving, it's not quite as much energy to push it and to keep it moving. So that's the difference between a static friction and a dynamic friction. All right, so which way is this box moving? So Hercules is putting an unbalanced force of 500 newtons on the block above. Can you tell which way the block is moving? This is an application of Newton's, several of Newton's laws actually in this question set right here. So which way is that block moving? He's pushing to the right with 500 newtons of force. And we discussed this briefly in class before school closed. The answer is no, you cannot tell which way the block is moving. The block does not need to be moving in the direction of the force. You must first know which way the block is moving at the time Hercules applies the force. So if that block was sliding towards him, big heavy block was sliding towards him, at the exact moment he put the force on it, it would probably push him back for a little ways. What the net force does tell you is if the block is sliding to the left towards Hercules and he starts putting a force to the right on the block, he'll be slowing the block down. And eventually, hopefully, he'll bring it to a stop. And if he were to keep pushing, then it would start to speed up back to the right again. But initially, you don't know just looking at a still picture which way that block is moving. Okay, so which way is this box moving? Well, here's what you can tell. If the block is standing still and he puts an unbalanced force of 500 newtons on it, it will speed up to the right. It'll start to move in the direction of the arrow. If the block is moving to the right already and he puts an unbalanced force of 500 newtons on it, it will speed up. It will continue to move to the right, but it will start going faster. 3, if the block is moving to the left against Hercules, this is the one we just talked about, it will be slowing down. He'll be slowing the block down if at the beginning of the situation it was already moving to the left. And number 4, if the block is moving in any other direction except toward or away from Hercules, it will be curving. So imagine that that block and Hercules are both coming out of the screen towards you. What he'll be doing is pushing that block. Imagine that block was coming right for your head. Then what he'll be doing is pushing to the right. He'll curve the block to your right so that it doesn't hit you in the head. In other words, he would cause the block to curve. Okay, so that takes care of this really short little lecture on Newton's third law. I'm going to have you watch a video that does nice animations and gives you several examples, and then you can go ahead and answer the question set. All right, have a good day. We'll see you tomorrow.